Darkness. Once there was only darkness. 15 billion years ago, the Big Bang occurred, giving birth to the universe. About 4.6 billion years ago, the Earth took form. Due to the strong gravitational force, a great mass of gases collected around the Earth, forming the atmosphere. The Earth's atmosphere and atmospheric movement gave rise to the ever-changing weather. Above the Earth's surface is the crucial troposphere, with 3/4 of the atmosphere's air and nearly all its moisture. Temperature decreases as altitude increases. The troposphere bustles with activity, a grand stage on which all kinds of weather perform. Above it, the stratosphere reaches an altitude of 55 kilometers. Next is the mesosphere, which extends to 85 kilometers above sea level. There is nearly no ozone. Temperature falls dramatically as altitude increases, and there's little moisture. Above the mesosphere is the ionosphere. Temperatures rise slightly along with the altitude, and air molecules are in a highly ionized state. Finally, we've arrived at the Earth's outermost boundary. This is the exosphere, a transitional zone separating the Earth from outer space. The multiple layers of protection that atmospheric gases receive made it possible for all life on Earth to survive and reproduce, and produce the Earth's climate. Water gives the climate its myriad faces. Our planet is a water world. 3/4 of the Earth's surface area is covered by water. Amid atmospheric movement, the Earth's water undergoes a cyclical journey similar to an epic poem. After receiving the sun's warmth, water molecules on the Earth's surface break free from the attractive force of nearby water, becoming water molecules released into the air. Thus begins water's journey through the atmosphere. On certain evenings or nights, the air temperature near the ground drops. When the air becomes too heavily laden with vapor, the vapor condenses on the Earth's surface into tiny water droplets known as dew. If wind speed is favorable and near-ground air holds ample vapor, the vapor will often condense, reducing visibility and forming fog. Large amounts of water vapor follow air currents upward to a certain altitude, where they meet cold air and condense into myriad small droplets or ice crystals, which form clouds. Though cloud droplets have a very small volume, by condensing and colliding with one another, they become larger and heavier. When the cloud droplets reach a certain size, they succumb to gravity, eventually overcoming air resistance and upward air currents to form rain. Mixed clouds have the best conditions for cloud droplet formation. Mixed clouds contain a large quantity of water droplets and ice crystals. When the water droplets collide with the ice crystals, they become fused to them, causing the ice crystals to increase in size and form snowflakes. If the air temperature below the cloud is less than 0 degrees, the snowflakes will fall to the Earth, forming snow. Snow turns the Earth into a fairy tale world of white. But there is also danger present. When the accumulated snow on a mountainside reaches a certain thickness, avalanches are prone to occur. Water constantly goes through its cycle. Its amazing power manifests itself in different ways, producing a vast range of weather. Climatic changes are inextricably linked to the water cycle and the cyclic atmosphere. As sunlight received by the Earth varies according to location, the difference in air pressure between the equator and two poles creates a global atmospheric circulation. Warm air rises from the equator, then moves to the south and north. Due to the Earth's rotational force, the surging air accumulates at around 30 degrees north latitude, then sinks, forming a subtropical high-pressure zone. When it reaches the Earth's surface, it divides into two currents. One returns to the equator, the other heads north to about 60 degrees north latitude, where it meets cold air and rises, advancing northward until it reaches the North Pole, finally returning to the equator. The same story occurs in the southern hemisphere. In this way, the atmosphere distributes heat from the sun and moisture throughout the Earth. With 6 wind zones and 7 pressure zones, the atmosphere carries heat from the scorching equatorial region to the frigid polar regions, adjusting the global climate. The Earth is a planet in the solar system. It spins on its axis and simultaneously revolves around the sun. The Earth's rotational axis slants about 66 degrees and 33 minutes relative to the ecliptic plane. Thus, during the Earth's one-year revolution around the sun, sometimes the northern hemisphere is tilted towards the sun, sometimes the southern hemisphere. Direct sunlight shifts between the north and the south regression lines in an annual cycle. The sun's changing angle of radiation causes the global pressure zones and wind zones to undergo cyclical changes, creating the 4 seasons. China has some of the world's most distinctive seasons. In winter, the climate in northern China becomes cold and dry, owing to high-pressure systems from Siberia. Summer is just the opposite. Seawater in the Pacific Ocean has a lower temperature relative to the mainland, causing a high-pressure zone, which brings hot weather and copious rainfall. In China, summer is a season of dramatic weather changes. Typhoons are regular visitors to the warm waters of the Pacific. Hot, humid air encounters low-pressure systems, forming numerous thunderstorms. Turning counterclockwise due to the Earth's rotational force, these storms enter low-pressure systems, forming giant tropical cyclones. Cyclones that reach a sustained wind speed of Category 12 are upgraded to typhoons. Typhoons often bring extreme weather. Strong winds and heavy rains pound the Earth, often putting people's lives and property at risk. In the wind family, there's another fearsome killer, the tornado. Tornadoes reach extremely high wind speeds, up to 200 meters per second. These many weather systems undergo a constant cycle of birth, development, and death. Completely different systems can also combine to form larger, more complex systems. Disruption of a system's internal order will cause global climatic irregularities. Water temperature in the eastern Pacific near the equator occasionally rises, a phenomenon known as El Niño. When this occurs, it changes the equatorial current and southeast trade winds, causing global climatic anomalies. Previously rainy areas will experience serious drought, while dry areas will receive torrential rains. The fact that El Niño occurs with increasing frequency is cause for concern. Global warming is quite possibly the main reason for this. increase of CO2 in the atmosphere due to human industry and lifestyle has intensified the greenhouse effect. If this continues, by 2050, global temperatures will rise by an average of 3.5 degrees. This constant increase in temperature causes the polar glaciers to melt, sea levels to rise, and a huge change to occur in the global climate. Many coastal cities would eventually be submerged. Our planet is fragile. Fearsome environmental disasters are constantly occurring. Environmental issues have already become serious concerns facing everyone on the planet. We need to enhance our knowledge of environmental protection. Starting with the little things close to us, we must adopt a variety of effective measures in order to care for and protect our beautiful green homeland.